All right, here we go. Last one in our series. So I tried to make one that was going to incorporate lots of different bits of information. And so I came up with this problem. It was like if we've got a boulder and or maybe a big rock or something, and we're trying to budge this thing. And so we get a big lever and we pull on that thing, and we're trying to get the rock to scoot as we pull on it, like this. Okay, now in order to actually do that, you need a lot of things would have to come together, right? You'd need a good strong lever arm, but you would also need a really strong fulcrum. And this problem is really about the fulcrum, okay? So let's start with what's happening, okay, to the bar. All right, the lever bar, all right, and it's pushing on the rock, but the rock is pushing back on it. So it's going to feel some force back this way from the rock. And maybe we'll call that F sub R, just like that. And so you can see the fulcrum is going to have to push outward like this, okay, and I don't know what to call that. We'll just call it F from the fulcrum, I guess. Like that. And of course, from the fulcrum's perspective, the bar is pushing on it like this. Okay. So just like that. And from the rock's perspective, the bar is pushing on it just like this. So we've got these interactions there, and both FRs are like we would consider them a normal force, but I don't think that really matters in this case. Now we've got some other forces acting on the rock. Okay, we're obviously going to have the weight of the rock. We're going to have a normal force here, and then since the lever is trying to push it to the right, then we're going to have some friction over here pushing that way. Okay, now let's think about chain of events, so to speak, here. Okay, what we want to get F of the fulcrum. Okay, we can't get F of the fulcrum unless we know F, capital F, and unless we know what the rock is doing here as well. Okay, and how we're going to get that is by knowing what's happening with the friction. So the friction is going to be like our key. If we can get that friction, then we can get F sub R. F sub R can lead us to getting F and F sub F. Okay, I hope that makes sense. So we'll start with the boulder in order to get that friction there. And so we've got FR. Woo, that's the wrong thing. We got FR pushing to the right, and our friction and its static friction is pushing the other way. Okay. Vertically on the boulder, the normal force is going to have to be the same thing as the weight, just like this. And so if we start doing some algebra, FR, it's going to have to be equal to FS, all right, which is always going to be less than or equal to mu times the normal force, which is mu mg here. Okay, now in order for the boulder to move, we need the maximum of that force, so it's actually equal. So we can come in here and we can say, well, FR is actually going to have to be equal to mu times mg, just like that. Okay, now if we think about the lever, the horizontal forces on the lever. Okay, so I don't care about this guy right here. All right, so this is going to be my horizontal forces on the lever. I've got my force pushing backward up there at the top. I've got my fulcrum pushing to the right here, but then we've got the rock pushing back on it like this. And so you can see my fulcrum has to do double duty. It's got to push against what we're doing, and it has to deal with FR, which is the friction here as well. Okay, so the fulcrum, we're really asking the fulcrum to do a lot. Okay, now how are we actually going to get any more information out of there? Because we've got, well, we know FR, but we don't know FF, the fulcrum, and we don't know capital F either. Okay, but that's okay because we have a whole nother equation, all right, which is our torque. Okay, so this equation over here. All right, now what I'm going to do is I'm going to put my pivot up here. That way, the value of F doesn't matter. And all I have to deal with is FF and FR. Okay, so with my pivot up there like that, then let's think about FF. FF is going to try and make it come around like this. So that's going to be a positive. So we'll come in here, we'll say plus FF. And that's at a distance of 2.4. Okay, but the rock is pushing in the opposite direction. So there's our FR, and it's at a distance of 2.7. Okay, now if that seems a little bit odd, it was just, we had to go down 2.4 and then we go down another 0.3. So 2.4 plus 0.3 gets us to our 2.7. Okay, and anyway, we can see here my fulcrum is going to be then this ratio 2.7 divided by 2.4 times whatever the rock is doing. So 2.7 over 2.4, and the rock is doing mu mg, just like that. Okay, now if we put in our numbers, what we end up getting for the force on the fulcrum turns out to be 1990. Okay, 1990, the year I graduated from college. How about that? Okie dokie. There we go. There's some good examples for you. Hopefully it gives you a little bit better idea how these things can work together. Okay.